Hello student, welcome to my channel Learn Physics. Today I will be discussing the solution of 29th January first half main paper. This discussion this discussion helps you to boost up your confidence in the next examination. I hope you will understand this. Please like, share and comment on this video. Now question number 1. A person observes two moving trains, A reaching the station and B leaving the station with equal speed 30 meter per second. One reaching the station and other leaving the station. Okay, both have velocity 30 meter per second. No problem. If both trains emit sound with frequency 300 hertz, okay, speed of the sound is 330 meter per second. Approximate difference of frequency heard by the person. Okay, look at this. This is the case of Doppler effect. The one source moving towards the observer and other source moves away from the observer. Look at this. When the source moves towards the observer, the n dash equal to this is the v by this is the v minus vs into original frequency n. Look at this. What is the v? Look at this. V is the 330 meter per second. So look at this. This is the 330 divided by this is the 330 minus 30 into frequency 300 hertz. So look at this. This is the 330 hertz. Okay. Now in case of other train which moves away from the observer, look at this, frequency becomes n dash. So look at this here, 330 divided by this is the v plus vs. So look at this, this is the 330 plus 30 into this is the 300. Okay, so look at this, this is the 330 by 360. Okay, into 300. No problem. Now look at this, 330 by 360. So this is the 11 by 12. Now 12 into 300. So this is the 25. Now 11 into 25. This is the 275. So apparent frequency of one is 275 and other is 330. So look at this, the difference of frequency. This is the 330 minus this is the 275. So this is the 55 hertz. Okay, option 4 correct. Okay. Now question number 2. A single current carrying loop of wire carrying a current I flowing anti-clockwise direction seen from the positive z direction and lying in the xy plane is shown in the figure. Look at this. This is the x-axis, this is the y-axis. So this is the xy plane. So the coil is on the xy plane. And from z direction, look at this, from this direction, the current is anti-clockwise direction. So magnetic field is directed along this direction. Okay, so lines of force, look at these lines of force directed along this direction. Okay, now the density of the lines of force decreases as we go from this point to this point. Okay, not the J component of magnetic field By at the distance A less the radius of the coil and on the positive direction of a z axis looks like. Look at this. So look at this, the magnetic field at this point directed this direction, magnetic field at this point directed opposite direction. So look at this, this is the positive direction, this also positive direction. Look at this is the negative direction and this is the positive direction. Okay, so graph looks like that. Now look at this is also positive, this positive. No, that's not correct. This positive not correct. Okay, this is positive but not correct, so this option is correct. Okay, now question number 3. A car is moving on a horizontal curve road with radius 50 meter. Okay, look at this here, r equal to 50 meter. Okay, the approximate maximum speed, we have to calculate velocity of the car. Okay, if friction between the tire and road is the 0.35. Okay, now look at this, In case of horizontal road, look at this. In case of horizontal road, look at this here. Centrifugal force is provided by the limiting force of friction. So look at this. In this direction, this is the mu mg, and in this direction, this is the mv square by r. Okay, no problem. Now put this value. So look at this here. Mu mg equal to mv square by r. Okay, therefore look at this, m and m cancel out. Therefore v equals to root under mu rg. Look at this here, mu equal to, this is the 0.34, r is the 50, and this is the 10. So look at this, this is the 34 into 5. Okay, root under, this is the 170. Now 170, this is a 30. So velocity is 13 meter per second. Okay, so this solution becomes extremely easy if you draw the free body diagram. If you draw the free body diagram at this point. Okay, understood? Next. Now look at this question number 4. Find the mutual inductance in the arrangement when a small circular coil, look at this, this is the small circular coil of radius r is placed inside a large square loop of side L, where L greater than r. Okay, the loop are coplanar and their center coincide. Now, first of all, we have to calculate the magnetic field at the center of the square. Okay, now look at this, the formula of magnetic field at the center of the square. This is the mu naught by 4 pi I by, this is the r, into, this is the sine theta 1 plus sine theta 2. What is sine theta 1 theta 2? Look at this. This is this angle. Look at this angle is theta 1 and this angle theta 2. So look at this here, theta 1 and theta 2 both are 45 degree. Okay, so magnetic field B, this equal to, this is the mu naught by 4 pi, this is the I. What is the perpendicular distance of the side from the center? This is the L by 2, and this is the sine theta 1, that is 45 degree, plus sine theta 1 45 degree, and as the square has 4 sides, so this is multiplied by 4. Okay, now sine 45 plus sine 45, so this is equal to 1 by root 2 plus 1 by root 2, that is root 2. So look at this, this is the mu naught I, this is the 2 root 2 into 4 divided by, this is the 4 pi L. Okay, now this and this cancel out. So look at this, this is the 2 root 2 mu I by pi L. What is the flux linked with the circular coil? Magnetic field into its area. So look at this here, phi equal to magnetic field 2 root 2 mu naught I by pi I into pi r square. Now this and this cancel out. This equal to mutual inductance Mi. Now I cancel out. So M becomes, this is the 2 root 2 mu naught I r square divided by, this is the only L. Okay, this is the L. Okay, this option 1 is correct. Okay, no problem. Next. Now question number 5. Speed of light in vacuum is dependent on the direction of propagation. No, 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 no. Speed of light in a vacuum is independent of direction of propagation. The speed of light in a medium is independent of wavelength of light. No, 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 no. It depends on wavelength. Okay. Now look at this. See, the speed of light is independent of motion of the source. Yes, the speed of light does not depends on velocity of the source. It always constant. This is the C. The speed of light in a medium is independent of intensity. Yes, this also correct. Therefore C and D correct. Look at this, option C correct. Okay, now question number 6. A block of mass M slides down the plane inclined at an angle 30 degree with acceleration g by 4. The value of coefficient of kinetic friction. Look at this. This is the inclined plane. This angle 30 degree. The acceleration of this block along this plane this is the G by 4. We have to calculate the coefficient of friction. Now look at this acceleration G by 4. This is the resultant force. This is the mg sin theta minus force of friction. What is force of friction? Force of friction equals to mu n, and n equal to mg cos theta. So look at this. This is the mu mg cos theta divided by m. Okay. So look at this. This is the g sin theta. So this is the sin 30 degree minus mu. This is the cos theta. So this is the mu into cos 30 degree. Okay. No problem. This is the g by 4. G cancel out. So look at this. This is the 1 by 4 equal to half minus root 3 by 2 into mu. So look at this. This is the root 3 by mu equals to half minus 1 by 4. So this is the 1 by 4. Now this and this cancel out. So this is the 2. So mu equals to 1 by 2 root 3. Okay, look at this, option 2 correct. Okay. Now question number 7. The surface tension of a soft bubble is 2 into 10 to the power minus 2 Newton per meter. Work done to increase the radius of the soft bubble from 3.5 centimeter to 7 centimeter will be. Okay. Now in case of soft bubble, work done W equal to, look at this. This is the 4 pi. This is the R2 square, that is 7 by 100 whole square minus 3.5 by 2 3.5 by 100 whole square. Okay, this is the 2 into s, because soft bubble has two surface, one inner surface and other outer surface. Okay, now look at this. This is the 4 into 22 by 7. Now 7 common. So look at this. This is the 7 square into, look at this. This is the 10 to the power. Look at this, 10 to the power 4 into, this is the 1 minus 1 by 4 into, this is the 2 into s. Now this and this cancel out. So look at this. This is the 28 into 22 into 10 to the power minus 4 into 3 by 4 into, this is the 2 into s is the 2 into 10 to the power minus 2. This and this cancel out. So look at this, 28 into 66 into 10 to the power minus 6 joule is the work done. Okay. Now look at this. This is the 28 into 0.66 into 10 to the power minus 4. Now 0.66 means 2 by 3. Now 2 by 3 into 28, this almost equal to 18. So look at this, option 4 correct. Okay, next. Now question number 8. This is the assertion and reasoning type question. Now assertion A. If dq and dw represent the heat supplied and work done on the system respectively, then according to the first law of thermodynamics, dq equal to du plus delta w. So this is the wrong statement. Now reason. The first law of thermodynamics based on the law of conservation of energy. This is the correct. So assertion is false and reason is correct. Look at this. A is not correct, but R is correct. Option 3 correct. Okay. Now question number 9. A cuboid of dimension 12 into 12 into L and has a charge Q placed at the center of the surfaces having area 4L square. The flux through the opposite surface through S is given by. This is a cuboid having dimension 12, 12 and this is the L. Now we have to place the charge at this point. We have to calculate flux at this point. Now if another cuboid of dimension 12 into 12 is placed over it. So look at this. This is a cuboid having dimension 12, dimension 12 and dimension also 12, and charge becomes at the center of the cuboid. So flux, so total flux is the Q by epsilon naught. So flux on each surface, this surface or this surface or this surface or this surface or this surface is Q by 6 epsilon naught. So look at this. So look at this, option A is correct. Okay. Now look at this question number 10. This is the matching type question. This is the physical quantity and dimensional formula of this. Look at this pressure gradient. Pressure gradient means pressure by distance. That is, look at this, this is the ml square t minus 2. Now energy density means the dimension of pressure. So look at this, this is the energy density. So this is the B, this is the A. Okay. Now, electric field, this is the force by charge. Okay. Now look at this, this is the C. Latent heat, this is the heat by mass. So look at this is the, look at this is the D. Therefore, 1D, 2B, 3A, and 4C is the answer. Okay. Now, question number 11. If the height of a transmitting and receiving antennas are 80 meters each, the maximum line of sight will be, look at this, the maximum distance of line of sight, this is the 2r, this is the hr, plus this is the 2r into ht, this is the height of the receiving antenna, and this is the height of the transmitting antenna. Now put this value, you look at this here, hr equal to, this is the ht, therefore this is the 2 into, this is the 2 into r is the 6.4 into 10 to the power, this is the 6, and this is the 80 meter. Okay. So look at this is a 2 into 10 to the power 3, and this is the 16 into 64. So look at this, this is the 2 into 10 to the power 3 into 16 into 2. So look at this, this is the 64 into 10 to the power 3. So this is the 64 kilometer. Okay. Look at this, option B is correct. Okay. Next. Now question number 12. In a young double slit experiment, two slits are eliminated with a light of wavelength. This is the 800 nanometer. The line joining A1P is perpendicular to A1 and A2. Okay, A1P is the perpendicular to A1 and A2. Okay, no problem. If the first minima is detected at the point P, okay, this is the first minima, the value of slit separation A will be. Now, what will be the path difference? Look at this, A2P minus A1P, this equal to the odd multiple of lambda by 2, because this is the condition for minimum interference. So look at this, this is the lambda by 2. Now look at this, A2P, this is the d square plus capital D square root under minus this is the d. So this is to lambda by 2. Now look at this, if d into, this is the 1 plus this is the d square by d square to the power half minus d, okay, equal to lambda by 2. This is the d plus this is the d into, this is the half into d square by capital D minus d. So look at this is the d square, and this cancel out, this and this cancel out, so this is the lambda by 2. Therefore, look at this, the d square by 2d, this equal to lambda by 2. This and this cancel out, so d equals to root under d into lambda. Now, what is d? D is the, this is the 5 centimeter. So 5 into, this is the 10 to the power minus 2, and this is the 800. So 80 into 10 to the power minus 8 root under. Therefore, look at this, 5 into 80. So look at this is the 400. So this is the 20 into 10 to the power, this is the minus 5. Therefore, look at this is the, this is the 0.2 into 10 to the power minus 3. So 2 millimeter is the separation between the two slits. Okay, next. Now question number 13. A stone is projected at an angle of 30 degree with the horizontal. Look at this. A stone is projected at an angle of 30 degree with the horizontal. Okay, no problem. The ratio of kinetic energy of the stone at the point of projection to its kinetic energy at the highest point. Now look at this. If this is, now look at this, if this is the trajectory, at the top point its velocity is the, this is the u cos theta. and at the initial point is the velocity u. So look at this here, k dash equals to k cos square theta. Therefore, k dash, therefore, look at this k by k dash. This is the 1 by cos square theta. And angle of, look at this angle of projection is the 30 degree. So 1 by, this is the cos square 30 degree. So look at this 1 by, this is the 3 by 4. So this is the 4 by 3. Okay. Look at this, option 1 is correct. Now question number 14. The threshold wavelength for a photoelectric emission from a material is 550 angstrom. The photoelectrons will be emitted when the material is illuminated with the monochromatic radiation from a. Now look at this. Here threshold wavelength, this is the 5500 angstrom. Therefore, electron is emitted with radiation having wavelength less than, this is the 5500. Now you know the wavelength of infrared radiation greater than 8000 angstrom. So A and B are not correct. The wavelength of ultraviolet light is less than 5500 angstrom. So emission takes place with the radiation with ultraviolet length. So look at this here, C and D are correct. Okay. Now question number 15. A radioactive element having half-life 30 minutes is undergoing beta decay. The fraction of radioactive element remains undecayed after 90 minutes. Look at this. Half-life T equal to, this is the 30 minutes. Here time T equal to, this is the 90 minutes. Therefore, number of half-life is the total time divided by half-life. So look at this number of half-life. This is the T by capital T. So this is the 3. Now amount of substance, now amount of radioactive element remain present. This is equal to n by n naught. This equal to half to the power. This is the 3. So this is the 1 by 8. Look at this option 2. So option 2 is correct. Okay. Now question number 16. Which one of the following statement is not correct in case of light emitting diode, LED? It is heavily doped PN junction diode. No, no, no. It emits light only when the forward bias. Yes, it emits light in forward bias. Okay. It emits light only when it is reverse bias. No, 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 no. Look at this. The energy of the light emitted is equal to or slightly less than the energy gap of the semiconductor used. Yes, this also correct. Therefore, B and D are correct. But C is false. Look at this. Here, B correct and D correct. C is not correct. So, none of the options are correct. Okay. Now look at this, the magnetic induction at the point O, look at this, at this point, due to the current arrangements, due to the current arrangement shown in figure will be. Now look at this is the, look at this current DE and this current along AB does not produce magnetic field at O because O is lies on the line of AB or D. Okay, the magnetic field produced, this is due to the BE and ET. Now look at this, due to this current the magnetic field is directed, this is the upward direction, and due to, look at this current magnetic field is also directed and magnetic field at O due to this also in upward direction. So this is added. So look at this 2 into, this is the mu naught by 4 pi I by, this is the distance, is the magnetic field. Look at this, option 4 is correct. Okay. Now question number 28. A bicycle tire is filled with air having pressure 230 kilopascal. Look at this. This is the pressure P1. Okay. At temperature 27 degrees Celsius. So look at this T1 equal to, this is the 300 K. No problem. Okay, the approximate pressure of the air, this is P2, in the tire when temperature increases to 36 degrees Celsius. That is T2 equal to, this is the 273 plus 36. So look at this, this is the 309 Kelvin. Okay, now look at this, here volume is constant. So at constant volume, this is the P1 by T1 equal to P2 by T2. Therefore, P2 equal to, look at this is the 309 by 300 into 270. Right? So 270. Therefore, look at this is the 1.03 into, this is the 270. So look at this is the 270 plus, look at this is the 8.1. So look at this is the 278 kilopascal is the pressure of the air. Now, question number 19. Two particles of equal mass move in a circle of radius r under the action of mutual gravitational attraction. The speed of each particle will be. Now look at this. Suppose this is the circular. Okay. Okay. One particle and another particle who are diametrically opposite points, so their center of mass at the center. Look at this mass experiences centrifugal force mv square by r. Look at this, the velocity of this mass is directed along this direction. Okay, look at this, here gravitational force, centripetal force, this is the g m square by distance is the diameter, so 2r whole square. So this force equal to this force. Now look at this is the mv square by r equals to g m square by, this is the 4r square. Look at this cancel out, this and this cancel out, so v equals to root under gm by 4r. Okay, option 1 is correct. Ratio of the thermal energy released in two resistors R and 3 are connected in parallel in the circuit. Now, thermal energy, when connected in parallel combination, is inversely proportional to the radius, because in parallel combination voltage is constant. So look at this equal to, this is the 1 by r is to 1 by 3r. So look at this is the 3 is to 1. Now option 3 is correct. Okay, now question number 21. A radioactive element X, this is the X92 242, okay, emits 2 alpha particle minus 2 alpha particle and 1 electron, that is beta minus particle, and 2 positron, that is 2 beta plus particle, and the product is, look at this is the Y234p. We have to calculate the value of p. Okay, now we have to apply the conservation of atomic number. Look at this is the 92. When two alpha particle emitted from this element, the atomic number decreased by 2 into 2. When an electron emitted from here, look at this, the atomic number is increased by 1 unit. When two positrons are emitted from this, atomic number decreases by 2. So this equal to P. Now look at this here, 92 minus 4 minus 1 equal to P. So look at this, P equals to, this is the 87. Okay, no problem. Now look at this question number 22. In a meter bridge experiment, the balance point is obtained if the gaps are closed by 2 ohm and 3 ohm. Okay, a shunt of X is added to 3 ohm resistor to shift the balancing point by 22.5 centimeter, the value of X. Now first of all look at this is the 2 ohm resistance, and look at this is the 3 ohm resistance. This is the left gap, this is the right gap. Now look at this is the meter bridge wire. Okay, now balance point is obtained here, suppose this point. Okay, this is the balance point. Suppose this length L and this is the 100 minus L. Now from the principle of meter bridge, this is the 2 by 3. This equals to L divided by, this is the 100 minus L. So look at this is the 3L equal to 200 minus 2L. So look at this is the 5L equal to 200. So L equal to, this is the 40. Look at this, when a shunt of X is connected with it, the balance point will be shifted from this point. Okay, suppose this is the balance length. Look at this is the 40 centimeter, this is the 22.5. So look at this is the 22.5 plus 40. So look at this length is the 62.5 centimeter, and this length becomes, look at this is the 37.5 centimeter. Okay, so look at this, R by S. S is the equivalent resistance between 3 and X. This equal to 62.5 divided by, this is the 37.5. Okay, no problem. Now this is, look at this is the 5 and this is the 3. Okay, so look at this is the 5s equal to, this is the 6. Therefore S equals to, this is the 1. Now 1.2 is the equivalent resistance between, look at this is the 3 and X. So 3 into X divided by 3 plus X, this equal to, this is the 1.2. Now look at this. So this is the 3.6 plus 1.2x, this equal to 3x. Therefore look at this, 3.6 equal to 3x minus 1.2x. So look at this is the 1.8x. Therefore look at this, x equals to 3.6 by 1.8. So this is the 2 ohm. So value of x, this is the 2 ohm. Okay, understood? Next. Now question number 23. A solid sphere of mass 2 kg is making a pure rolling on a horizontal surface with kinetic energy 22 with kinetic energy 2240 joule. Okay, the velocity of the center of mass of the sphere will be, now look at this is the rolling motion. For rolling motion, the total kinetic energy, this is the half mv square into 1 plus k square by r square. Now this equal to, this is the 22.40 joule. Okay, now for solid sphere, its moment of inertia is the 2 by 5 mr square. So look at this is the mk square equal to 2 by 5 mr square. So look at this here, k square by r square, this is the 2 by 5. Now put the value here. So this is the half into m is the 2 kg into v square, and this is the 1 plus, this is the 2 by 5, this equal to 2240. Now this and this cancel out, so v square equal to, this is the 2240 into 5 by 7. Now look at this is the 320. Now 320 into 5, so this is the 1600. V square equal to 1600, so v equals to 40. So velocity of the sphere is 40 meter per second. Okay. Question number 24. As shown in the figure, look at this, P1, P2, P3. Okay. Shown in the figure, three identical Polaroid. Look at this is the P1. Look at this is the P2 and this is the P3. Are placed one after another. The path axis of P2 and P3 are inclined at an angle of 60 degree and 90 degree with respect to the axis of P1. The source as has an intensity of 256 watt per meter square. Now we have to calculate the intensity at this point. Okay, look at this. This is the numerical related to Malus law. Now according to Malus law, I equal to, this is the I naught cos square theta. Okay. Now look at this. The angle between look at this angle between P1 and P2. This is the 60 degree. Angle between P1 and P3. This is the 90 degree. So angle between P2 and P3. This is the 30 degree. Okay. Now look at this. This is the unpolarized light of intensity 256 watt per meter square. After passing through P1, its intensity becomes, this is the 128, half of the original intensity. Now, after passing through P2, this becomes 128, this is the cos square 60 degree. Okay. Now, value of cos 60 half, so cos square is 1 by 4. So look at this is the 128 by 4. So look at this is the 3 2. Okay, now after passing through P3, its intensity becomes, this is the 32 cos square 30 degree. Now cos square 30 degree means 3 by 4. So look at this, 32 into 3 by 4, that is the 24 watt per meter square. So 24 watt per meter square is the intensity at the point O. Understood? Next. Now question number 25. If point charge Q1 equal to 4Q naught is placed at the origin. Look at this. Suppose this is the x-axis. This is the origin. So 4Q naught charge placed at this point. Okay. Another point charge Q2 equal to minus Q naught is placed at x equals to 12 centimeter. So look at this. This is the x equals to 12 centimeter. This is the charge minus Q naught. Okay. Charge of proton is Q naught. The proton is placed on x-axis so that the electrostatic force on the proton is zero. In this situation, the position of the proton from the origin is, look at this, proton should be placed this side because these two charges, look at this, these charges and these charges are opposite in nature. So proton experience zero force if the proton placed only at this position. Suppose proton placed at this position. Okay, this is the x naught. No problem. Experiences due to minus q naught charge, the proton experiences forces F1 along this direction. Due to 4 q naught charges, proton experience force along this direction. Suppose this is the F. If F1 equal to F2, then net force acting on the proton is zero. Understood? So look at this here, F1 equal to, this is the F. Now the distance between minus q naught and q naught is x naught, and distance between 4q naught and q naught is 12 plus x naught. So look at this, this is the u naught into q naught into k divided by x naught square. This equal to k into 4q naught into q naught divided by, this is the 12 plus x naught whole square. Okay. Now look at this q naught, this q naught cancel out, k cancel out. So look at this is the 1 by x naught whole square. This equals to, look at this 2 by, this is the 12 plus x naught whole square. Okay. So 1 by x naught equal to 2 by, this is the 12 plus x naught. Therefore, 2x naught equal to x naught plus 12. Therefore, x naught equals to 12. Okay, no problem. So, position of the proton, look at this. This is the 12 centimeter and this is the 12 centimeter. So, 24 centimeter from the origin. Okay, next. Now, question number 26. In a certain elastic conducting material is stretched into a circular loop. Okay, it is placed with the plane perpendicular to uniform magnetic field B equal to 0.8 Tesla. When released, the radius of the loop starts shrinking at the constant rate of 2 centimeter per second. If R be the radius, so here look at this, dr by dt equal to, this is the negative sign of 2 by 100, this is the meter per second. Okay, no problem. Now, the induced EMF in the loop at the instant when radius of the loop be 10 centimeter. Okay, so look at this here, R is equal to 10 by 100 meter. Okay, we have to calculate induced EMF. B is equal to 0.8 Tesla. Okay, now, now look at this here, induced EMF E equals to d dt of, as it has one turn, so B into A. Now look at this, B into here dA by dt. Look at this here, B into, this is the d dt of pi r square. Look at this, so look at this, E equal to, therefore 2 pi r B dr by dt with negative sign. Okay, so look at this. This is the 2 pi. R is the, look at this, 10 by 100. B is the 0.8 and dr by dt is the negative sign of 2 by 100. Okay, this is the volt. Okay, this is the negative sign. Now this negative sign and this negative sign cancel out. Okay, this and this cancel out. So look at this, 2 pi into zero point 0.8 into 2. So look at this. This is the 3.2 pi into 10 to the power minus 3 volt. Okay. So look at this. This is the 10, almost 10 millivolt. Okay. Look at this. This is the 10. Okay. Now question number 27. 0.8. Look at this. A tennis ball is dropped from the height of, look at this. This is the height. Okay. This height. This is the 9.8 meter. It rebounds to a height of 5 meter. Okay, now it rebounds to a height of, this is the 5 meter. Okay, this is the 5 meter. The ball comes in contact with the floor is 0.8 second. The average acceleration during the contact is, okay, g is the 10 meter per second square. Now we have to calculate velocity just before touching the ground. So look at this velocity v1, this v1 is equal to root under of, this is the 2g h1. Now look at this here, h1 equal to, this is the 9.8. So 2 into g is the 10 and this is the 9.8. So look at this is the root over of 196. So this is the 14 meter per second. No problem. Now suppose velocity after impact be v2. And due to this, it rises the height 5 meter. So look at this, V2 equals to root under of 2GH2. What is H2? H2 is the 5 meter. So look at this is the 2 into G. G is the 10 and this is the 5. So this is the root 100. So this is the 10 meter per second. Okay, now look at this. If velocity in the upward direction taken is positive, so acceleration A equal to, look at this, 10 minus 14 divided by, now time of contact is equal to 0.2 second. So look at this is the 0. Now look at this is the 24 by 0.2. So look at this is the 120 meter per second. Okay, next. Now question number 20. A body cools from 60 degree to 40 degree in 6 minutes. If the temperature of the surrounding is 10 degrees Celsius, then after next 6 minutes the temperature will be. Okay. Now according to Newton's law of cooling, the rate of cooling theta 1 minus theta 2 by T is directly proportional to the difference of temperature between the source and surrounding. So look at this. This is the case. Now in the first case, theta 1 is 60, theta 2 is 40. T is the 6 minutes. So we have to calculate K as theta naught is given as 10 degrees Celsius. And so look at this. This is the 60 minus 40 divided by 6. This equals to K into, look at this, 60 plus 40, 50. 60 plus 40, 100 by 2. So this is 50 minus 10. Now look at this. This is the 20 by 6. This equals to K into 40. Look at this and this cancel out. This is 2. Therefore, K equals to 1 by 12. No problem. Suppose temperature after 6 minutes is theta. So look at this here, 40 minus theta by 6. This equal to 40 plus theta by 2 minus theta naught with constant K. Therefore, 40 minus theta by 6 into, this is the K equal to, K is the 1 by 12 and this is the, look at this, 40 plus theta by 2 minus 10. Okay, now look at this and this cancel out. Okay, now look at this is the 40 minus theta into 2. So this is the 80 minus 2 theta. This equal to, this is the 40 minus 20 plus theta. Now look at this is the 40 plus theta minus 20 by 2. Okay. So look at this from here. This is the 160 minus 4 theta. This equal to, this is the 20 plus theta. Okay. Now look at this. This is the 160 minus, this is the 20. So 140 equal to, this is the 5 theta. Therefore theta equal to, look at this. This is the 28. Therefore temperature after 6 minutes, this is the 28 degrees Celsius. Okay, understood? Next. Now question number 29. Two simple harmonic waves having equal amplitude of 8 centimeter and equal frequency of 10 Hz are moving along the same direction. The resultant amplitude is also 8 centimeter. The phase difference between the individual wave in degree. Now look at this here. A1 is equal to A2 equal to 8 centimeter. Resultant amplitude is also 8 centimeter. Now the resultant amplitude due to superposition A is equal to, this is the root under of A1 square plus A2 square plus 2A1 A2 cos phi. Now put this value. Look at this. A equal to 8. So this is the 8 square. This equal to 8 square plus 8 square plus 2 into 8 into cos phi. Now this and this cancel out. So look at this. 0 equal to, this is the 64 plus 2 into 64 into cos phi. Therefore, look at this from here, cos phi equal to, this is the negative sign of 64 by 2 into 64, so minus half. So look at this, cos equals to 120 degree. Therefore, phi equals to 120 degree. Okay, so phase difference, this is the 120 degree. Okay, now question number 30. A 0.4 kg mass takes 8 seconds to reach the ground when dropped from a certain height P above the earth's surface. Okay, the potential energy in the last second of fall in joule. Okay, now we have to calculate the distance traveled by 0.4 kg mass in 8 seconds. So look at this, the distance h8, this equals to u plus, this is the half g into 2t minus 1. Okay, so look at this is the 0, this is the half into 10, and this is the 2. 2 means this is the 2 and t means 8 minus 1. Okay, so look at this, this is the 10, so 5 into, this is the 15. So look at this, this is the 75 meter. So change of potential energy delta equal to, this is the mg, this is the h8. Now m is the 0.4, g is the 10, and this is the 75. So look at this, this is the 4 into 75 joule, that is, this is the 300 joule is the change of potential energy. Okay, many thanks for watching this video. This video will be extremely helpful for your preparation in NEET, main and advanced. For getting the higher percentile, always connect it with my channel. Okay, thank you.